Have you ever been out walking and picked up a really cool looking, colorful rock and just wondered, what's actually inside this thing? Well, today we're going to dive into the world of the engineers who answer that exact question, but on a massive industrial scale. We're going to explore the whole science of mineral processing, and we'll do it by following the journey of an expert in the field. It turns out they're literally engineering the earth.
So, let's meet Abbas Karami. His journey into this world, well, it didn't start in some university lab. It started in the riverbeds of his hometown, which just happened to be rich in minerals. While other kids were playing, Abbas was collecting stones, totally fascinated by their colors and their textures. His father even used to joke that he was a miner way back then, long before he even knew what the word meant.
So how does a hobby like that, collecting rocks, turn into a super high-tech career? Well, for Abbas, that early passion was really just the first step on a path that would take him from a riverbed all the way to the cutting edge of modern engineering. His academic journey actually started in what's called extraction engineering. That's the part of mining that's all about just getting the rock out of the ground. But pretty quickly, he realized what he was really fascinated by was the chemistry of it all. And that little discovery led him to specialize in mineral processing, which is this amazing field that blends chemistry, metallurgy, and engineering, all to unlock the valuable stuff hidden deep inside the ore.
Okay, so what is mineral processing really? It's one of those fields that most of us have probably never even heard of, but I guarantee you our modern world would grind to a halt without it. It's that absolutely critical step that happens after the digging stops, but before any kind of manufacturing can begin.
To put it simply, mineral processing takes tons and tons of raw, messy ore, which might only have a tiny, tiny fraction of anything valuable in it, and it separates the good stuff from all the waste. You can almost think of it as alchemy, but on an industrial scale, and, with a whole lot of science.
And the process itself, it's just a massive undertaking. It all kicks off when these gigantic dump trucks deliver the raw ore. Then this phase called comminution begins, which is just a really fancy word for crushing and grinding rocks down into super fine particles. After that comes beneficiation, where all sorts of clever chemistry and physics are used to pull out the minerals you actually want. And then finally, there's the hugely important environmental step of managing all the leftover waste and water.
And this is what makes it so complex and so cool. Mineral processing engineers aren't just one thing. They're part chemist, part metallurgist, and part environmental scientist. They really have to get their heads around everything from complex chemical reactions to fluid dynamics, all the way to project management.
And if you want to understand the sheer scale we're talking about, just listen to this. Abbas remembers the very first time he saw something called a sag mill. It's this gigantic machine that just grinds ore. He said its size was just unbelievable. This one machine processes over 1,000 tons of rock every single hour. That's like crushing the weight of 5 blue whales every hour of every single day. Just mind-boggling.
But, as you can probably guess, operating on that kind of incredible scale brings some equally incredible challenges. The easy days of mining are pretty much over, and that puts mineral processing engineers right on the front lines of innovation.
So here's the fundamental problem they're all facing. All around the world, the richest, easiest to get to mineral deposits, they've mostly been mined already. The low-hanging fruit is gone. And what does that mean in practice? It means that today's engineers have to work with much lower quality ore, which makes their job way, way harder. They have to figure out how to extract these tiny amounts of valuable material from enormous amounts of waste rock. And to do that, you need smarter, more efficient, and way more sophisticated technology than ever before. And the challenges just keep piling on. This industry uses immense amounts of water and energy. So these engineers are in this constant battle to shrink their environmental footprint, to manage these huge piles of waste material, and to figure out how to operate in parts of the world where water is getting more and more scarce. The pressure is just relentless. It's perfectly captured by this little inside joke that Abbas shared. He said that if one of those giant grinding mills could talk, it would just be screaming, "Pour less, leave me alone." But it can't ever get a break, because if that mill stops, the entire multi-million-dollar operation grinds to a halt. So, given all those challenges, you might think the industry is kind of in trouble, right? But what's actually happening is that these pressures are forcing it to become incredibly innovative. The future of mining looks very, very different from its past.
And these new frontiers are just fascinating. There's something called urban mining, which is literally extracting precious metals from our old electronics. Engineers are also finding brand new value in non-metallic minerals like silica. There's even nano mining, creating these ultra-valuable materials for things like cosmetics. And of course, AI and automation are popping up everywhere, making everything safer and way more efficient.
In fact, Abbas thinks that nanomining could become its own specialization entirely. The idea is you take the final product, like, say, a pure bar of silver, but then you go one step further and process it into high-value nanoparticles for really specialized industries. It just goes to show how the field is always evolving.
So we've talked about the science and we've talked about the future, but what is it actually like to work in this field day to day? Well, it turns out it's a career of some pretty extreme contrasts.
Okay, let's be honest about it. The work is tough. It's almost always in these remote, sometimes desert locations, far away from city life and from your family. But the trade-off for that hardship is, well, it's pretty significant. The income potential is huge, right up there with the oil and gas industry. And because of all those challenges we just talked about, the demand for really skilled engineers is only going up.
But that tough reality, it really isn't for everybody. According to Abbas, about half, 50% of his university classmates ended up leaving the field completely after they got a taste of the working conditions. That number is a pretty stark reminder that this isn't just a job you clock in and out of, it's a demanding lifestyle.
And so his advice is really simple and direct. Do your homework. Truly understand what you're signing up for before you commit. This is not your typical 9-to-5 office job. But for the right person, for someone who is prepared for those challenges and who really has a passion for the work, the career can be incredibly rewarding.
So from a kid picking up colorful rocks by a river to an engineer designing the future of materials, the whole journey really comes full circle. This field is fundamentally about reshaping our planet to build our world. Abbas calls it engineering the earth. The stuff in your phone, in your car, in your house, it all started here. And that is a massive responsibility, but it's also a massive opportunity. The only question left is, who's ready to take on the challenge?